Welcome back to the Fox Den, everyone, a podcast series from West Shore Community College. We are reviewing the winter 2023 book of the semester, Project Hail Mary by Andy Weir. This episode covers chapters 13 through 18, where we chat about the book's physics with Professor Joe Grahusky, character development with librarian Patty Skinner, and biology with Professor Paul Belinsky. Hello, I'm Wade James, professor of mathematics, and I've actually visited NASA's Neutral Buoyancy Lab at Johnson Space Center in Houston, Texas.
Hi, I'm Joe Grahusky, professor of physics. I've also visited Johnson Space Center, and I drove the lunar lander around.
Hi, I'm Patty Skinner, director of library services, and I don't want Rocky to watch me sleep.
Hi, I'm Paul Belinsky, professor of biology, and I think simplicity is beautiful.
In Chapter 13, Ryland suspects that Rocky's crew perished due to radiation poisoning, which triggers a flashback to a meeting with Dr. Loken. Loken discovered that astrophage can absorb radiation and plans to line the hull of the Hail Mary with a thin layer of astrophage to protect the crew.
In Chapter 14, Rocky shares details of his home world, Irid, which has a thick atmosphere and strong magnetic field. Rocky also shares details of his physiology, which includes mineralized skin, bone made of metallic alloy, and liquid mercury blood.
In Chapter 15, Rocky builds a self-contained life support sphere, which allows him to board the Hail Mary. Now roommates, Ryland and Rocky devise an experiment to collect astrophage from Tau Ceti.
In Chapter 16, flashbacks introduce the original crew of the Hail Mary, which includes Captain Yao, the commander, Ilyukhnya, the materials expert, and Martin Dubois, the engineer. In the meantime, the Hail Mary travels towards Tau Ceti, eventually orbiting an astrophage-rich planet named after Rocky's mate, Adrian.
In Chapter 17, Ryland recalls his training at the Neutral Buoyancy Lab at NASA's Johnson Space Center, where he tested the in-vacuo microbiology equipment. Ryland uses the equipment to collect a sample of astrophage from Tau Ceti's Petrova line, which suggests that the atmosphere of Adrian has an astrophage-eating predator.
In Chapter 18, flashbacks introduce Steve Hatch, who designed the quartet of Beetle spacecraft programmed to return to Earth. If Ryland and Rocky can collect the astrophage-eating predator from Adrian's atmosphere, they can launch the Beetles packed with predators and hopefully save their homeworlds.
Joe, what was something in these chapters that you really geeked out about?
Right at the outset of Chapter 13, reasonably early, they started talking a little bit about particle physics and what matter is made of. For a long time, humans have asked what matter is made out of, and we've gotten better answers. It's made out of molecules. Oh, wait, it's really made out of atoms. Wait, there's electrons in there. Protons and neutrons are found. In chemistry, we would learn that the atom is made up out of electrons, protons, and neutrons. One of those seems to be fundamental, and the other two do not seem to be. Anyone want to guess which one's fundamental?
The electron.
We have not broken up an electron. It seems like that one is unbreakable. That's a family of particles called leptons. They don't seem to be breakable into smaller pieces, but the proton and the neutron, those can be broken up into things called quarks.
Up, down, top, bottom, strange, charmed.
That's right. The quarks have funny names, up and down. That's what the proton and the neutron are made up out of. We can break up the proton and the neutron, but we can't really break up the lepton. For each of those types of particles, it turns out each one has something called an antiparticle partner. Like there's an opposite version of that type of particle. So there's actually kind of two lists, one of the ordinary particles and one of the antiparticles. The only difference between the antiparticles is that they have opposite electric charge. So if the proton is positive, its antimatter partner is negative, which means that they're going to attract each other. And if those particles get together, they undergo this process called annihilation. And that means that the particles just completely obliterate. They're gone. They don't exist anymore, and they convert all their energy into other stuff. If it's relatively low energy, then it's just going to be light, like they give off a little flash of light that we'd call gamma rays. If it's higher energy, you can actually get it to spontaneously create new types of particles. And that's actually what we do in particle accelerators all the time. In my classes, I usually refer to their work as like caveman science with a really big budget. They just like smash protons and antiprotons, or protons and protons together, just like cavemen smashing a rock together to see what comes out. And we just have really fancy detectors that looks at the particles that are spraying out to see if we're right about how we think particles are put together. That process of annihilation is referred to in the book because that's supposed to be sort of the energy mechanism of the astrophage. These protons that are already inside the astrophage, which collide with each other, and they create pairs of neutrinos. And somehow the astrophage can store these neutrinos inside of itself, and it can use those neutrinos to annihilate and give it energy when it needs to. So the idea here for the story is that these neutrinos with a very tiny mass that usually are very innocuous are somehow fueling this sun-devouring organism.
How feasible is it that the astrophage cell membrane could absorb the radiation and then use it? And that's why they line the hull of the ship with astrophage, so it would absorb this radiation.
I would call that a definite fiction element. I don't think any ordinary material could interact with neutrinos like that. So like one single cell somehow containing these neutrinos is entertaining and interesting, but like the actual material science and particle physics likelihood of it, I would say, is reasonably low. One thing I would add about neutrinos is that their mass actually does seem to be in the right ballpark for infrared radiation. Since the mass is so small, if you did apply your E equals mc squared, turning mass into energy, the mass actually ends up being in the infrared sort of wavelength in terms of the energies that would be involved.
Patty, what was something in this section of chapters that you found very interesting?
Well, in this section, we really see a lot of character development, and we see a kind of relationship start to form between Rocky and Ryland. They really come together because they have a common purpose. And I really think that they need one another in this purpose. Like, they both have to save their entire home planets and home species. It's a big job. And I really don't think it's a one-man job. So I think they really come together, and we kind of see this friendship start to form where they really rely on one another and they really enjoy one another's company, which is kind of interesting to see the way they interact and become friends.
There was a point in the story where Rocky was feeling a little down about himself and that he wasn't an engineer. He was just the maintenance guy, that when things broke, he would fix them. And Ryland said, no, you're actually doing a great job. Look, you've made it this far. Through most of the book, Ryland is in awe of this alien creature. And then Rocky started to feel down about himself. And it was Ryland that kind of stepped up and said, no, man, come on, you're doing a great job. Like, we're going to figure this out together. You know, I'll do the science stuff and you can do the building stuff, and we're going to work on this together. I have deficiencies and you have deficiencies. They both have gaps. And this comes from the movie Rocky, when he's talking about meeting Adrian and he says, I have gaps and she has gaps. So together we fill each other's gaps.
There was also some good moments between them when Ryland didn't want to tell Rocky that he was on a suicide mission, that was like too painful for him to admit. And he didn't want to maybe make Rocky feel bad that he would be losing his friend. Once he did have the courage to confess that he wasn't ever going to make it back to his home planet, Rocky came through and saved the day and told him that he would be able to get him back to his home planet. So there's really a lot that happens between the two of them that really solidifies a really strong bond. I don't know what you guys think of Ryland as a scientist, but like, he feels kind of like an unlikely hero to me. Like, he was a science teacher. Was he the most qualified to be on this mission in the first place? Could he have done this all on his own? And I don't think so. I think he really needed this ally that came through to help them achieve their mission.
In the book, they do paint science in a little bit of a dogmatic light, that there's like a certain consensus in that he didn't happen to be on the inside of that consensus. So he was sort of excluded from the field that he was in because he rocked the boat a bit. But it was also some personality differences, because in science, you generally can disagree. But it seems like he was maybe a little too strong in the way that he disagreed. You know, they talk about in the beginning of the book how he burnt some bridges.
In grad school, I encountered a little bit of this. There's some folks who could disagree productively And there's some folks who would not disagree productively. You would just essentially not be able to talk to them about things. It was much more pleasant to work with folks who you could agree to disagree with because there wasn't enough evidence on a point, and really frustrating to try to collaborate with someone who just thought differently and wasn't going to be convinced any other way. I certainly had some people in mind when I was reading about that aspect of Ryland's character.
Something else that I really thought about a lot as a literary construct from this book, a concept that something's going to save the day. There's really no explaining it, but somehow there's going to be a Deus ex machina moment, and it's God from a machine. And it's just basically unexplainable. Nothing else would have worked. And astrophage is both the problem and the solution. Astrophage presents itself as a problem, but it's also going to be the rocket fuel that's going to help get them to the solution.
So not only is astrophage destroying the sun, which is going to cause global catastrophic weather patterns, but it's also the fuel that the ship uses to get to Tau Ceti. And it's also the protective skin around the Hail Mary that protects the crew from radiation. It's the villain and the hero.
And I think that's a clever bit of writing, a very elegant solution.
Paul, tell us about panspermia.
Panspermia is the hypothesis that life evolved in one place in the universe and it traveled to all the other places that life exists via meteor, comet, why not a spaceship too, right? Since we're bringing out all the possibilities. Panspermia is aiming to answer a particular question, though. That question is, why would life in different parts of the universe look so similar on a cellular level, on a physiological level between Rocky and Grace? Why is there so much similarity between life? And in order to understand how panspermia works, we have to understand the dueling hypotheses. So did life arise in one place and spread out? Or did life arise independently in many similar ecologies in different places in the universe? While the concept of panspermia is not implausible, I personally hate it because in science, we want to find the simplest explanation, a concept called parsimony. Don't overcomplicate things. Don't overcomplicate the explanation. The most likely path is the path that's the simplest or has the smallest number of steps. So let's compare the number of steps in each of these two hypotheses and see which evidence we have. At the center of panspermia is the idea that life moving across the universe is more likely than life arising independently in many places. While it might be possible that life could travel on a meteor or comet, space is a pretty hard place to survive. Organisms would have to be likely prokaryotic and unicellular, so kind of small. And then life would get to these disparate places and then diversify and adapt once it got to its potential homes, and then still land on kind of a similar outcome in eukaryotic life, or life that has many membranes inside each cell. It's essential to making multicellular organisms. On the flip side, you could ask, how likely is life to spontaneously assemble from a lifeless planet? Well, the cool thing is we have a beautiful set of experiments to show that this might actually be fairly doable to create those conditions for life to arise. Starting in the 50s and continuing to this day, biologists have done a series of experiments that try to replicate those early Earth conditions to see if our macromolecules of life, those carbohydrates, lipids, amino acids, and nucleic acids, would arise on their own. The first in these series of experiments were called the Miller-Urey experiments, and images of these beakers and things haunt me to this day because I was lucky enough to take my college chemistry class in the building where Harold Urey was a professor. So I took it in Urey Hall. It's not where the experiments happened, but it is where my grades were posted under pictures of those experiments. So yes, still haunting me. These were closed chambers that were started in 1953 and then reopened in 2007. And they showed that you could spontaneously create the 20 amino acids that are necessary to build all of our proteins from this primordial soup. Amino acids are the building blocks of our proteins. So it's not like we're making proteins, but rather that we're making the building blocks that could build proteins. There's a parallel set of experiments that actually show that RNAs are able to form in that same primordial soup. Maybe one day in those same vials, we'll eventually get bubbles of lipids that we'll potentially call cells. But we're still a long ways away from that because we've been running it for 60 years, not a billion. I think it's way more likely that evolution in parallel conditions in many different places of the universe is the reason why life is so similar. And now for full disclosure, parallel evolution is a concept that's very near and dear to my heart because it was a major focus of my 6-year PhD thesis. I investigated whether evolution could land on a similar solution in wild varieties of corn. And guess what? We found that, yeah, given similar starting material, selection repeated itself in 2 parallel adaptations from low altitude to high altitude, meaning that those corn varieties, despite the fact that they were running these experiments in central Mexico to the high altitude mountains there and the Andes, that there seemed to be this similar outcome. Evolution really does have the potential to just repeat itself. So count me amongst the skeptics of panspermia, and instead amongst the group of folks who think that life is more likely to rise independently multiple times, even potentially allowing it to look similar because the ecology is similar, despite the fact that those exist in very different places.
Do we have current examples of this happening?
I think I've got 2 data points that might be kind of exciting to hear about. So the first, do plants succeed when you take them out of their native range? Well, look no farther than invasive species, right? Where we have similar ecologies. It's a temperate environment. They have similar water levels, similar soils as well, but the biological pressure is so different. They have different species that they're competing with. And most importantly, they have different predators. And so a plant that goes from somewhere like East Asia that finds its way over here is not going to be recognized by any of the predators out here and therefore flourish, just absolutely take over. It really does a great job of being an invasive species. In terms of the parallel evolution, cacti are native to the Americas. So what do you find in Africa? There's a lot of deserts in Africa. Do you find cacti in Africa? There are plenty of places that are exactly the same to what you'd see in California, northern Mexico. It's the exact same desert. But Africa doesn't have cacti because cacti evolved in the quote unquote New World, in the Americas. In Africa, there's a parallel family of plants called the Euphorbiaceae or euphorbs that are so similar in how they look to cacti. They're succulents. They've evolved this like the same exact method of doing photosynthesis. They've got similar flowering patterns. So they have a very similar life history to cacti, but because we didn't have the progenitors of cacti in Africa, the outcome ends up being the same. The plants look very similar, but they're completely genetically unrelated. So it is this idea that like, yeah, similar ecologies in different places ends up creating flora that ends up looking very similar. We also have the same case in a lot of fauna. You'll have things that will try to fit that same ecological niche, and biomechanically, it just makes sense to try to have an organism that does X, Y, and Z the same way in different places, even if they started from completely different starting points.
As Rocky was describing his blood system and how there are single-celled organisms that essentially act the same as the single-celled organisms that are in us. We grow teeth in our mouth. Rocky grows teeth all over his body. He's got mineralization. His nerves don't operate on electrical impulses like ours do. They're light impulses. When Rocky eats, his bottom part kind of opens up, the shell pulls back, a big blob of stuff comes out. And then he flips over on his back, grabs this food that he's ripped apart that appears to be meat, just kind of puts it in the same place where the blob came out. Everything seals back up. And then he goes into a food coma. Patty, when you were discussing the friendship and the dynamics of the friendship, how there were things that they reluctantly wanted to share with each other. Rocky really didn't want Rylan to watch what's going on. And Rylan, of course, plays the science card. He says, I want to watch this because of science. You know, I want to learn about you. And so Rocky's like, okay, I understand.
I think that that is telling of like the culture that the two different beings have. Like the human culture is that you want to share a meal together, and that's important to us and significant. And that the Iridian culture is that they watch one another sleep, and that was really important to them. So I think that's really showing the way these two characters are relating to one another and how they're bonding.
And I think that actually you don't need to look all that far away. All of these comparisons about the Iridians all of this is actually found here on our planet. The mineralization is something that we see when we talk about crustaceans. They have an exoskeleton in the same way that Rocky would mineralize that exoskeleton to deal with the particular pressures that they have. And on our planet, they're dealing with predators. On Rocky's planet, it's dealing with the environment. That story of his digestion, where he's putting it all in and taking it all out of the same opening. But there are organisms on our planet that do that. They have one directional digestive system. So it was really cool to see how the author, Andy Weir, took from existing life forms on planet Earth that we see every day and invented an alien species from that. Like, it's crazy to think about that. The Iridian already seems so foreign to us, but really it's just the combination of things that we see on Earth. It's so hard to think about a truly alien life form because there's so many ways to make life work on our planet. Once you understand really what's happening on a molecular level, we are living amongst aliens. I think that Rocky did a little bit of digestion outside of him, which would be saprotrophy. And that is something that we see in fungi. So Rocky's this weird combination of crab, flatworm, fungus, plus calculator for his head. He's like this weird amalgam of all kinds of organisms that we find regularly on our planet, but you put them together into a like echolocating mineralized box, and all of a sudden it certainly feels like an alien.
Pop culture references or favorite quotes?
Maybe I have two short ones. One, when they were talking about the selection of the astronauts, I like the reference to the right stuff, the astronauts having the right stuff, which in the context of the book, it was the specific gene that would make them tolerant to the travel. But of course, the right stuff was a story movie about the selection of astronauts out of the fighter pilot programs. That there's a movie called The Right Stuff that probably a lot of our students haven't seen. It maybe isn't the fastest moving movie you've ever seen, but it is entertaining and interesting, I think. The other, protons zipping around inside the astrophage, which is really a hydrogen ion. A whole bunch of hydrogen ions inside this organism would mean that it's highly acidic. The hydrogen ion is a measure of how acidic something is. So that would mean that it's largely acidic on the inside, which you've got this alien that's acidic. And to me, that sounded a whole lot like the xenomorph from when I was a kid. And the original Alien movie was an awesome movie. I mean, the ones after that were just okay. They were fine, but the original Alien movie was awesome. So students should definitely at least see Alien, the original.
Yeah, talk about a defense mechanism. You can't eat this creature because it has acid for blood. Patty, you alluded to my favorite quote. There was an awkward moment between the two. They use the C word, culture. We have an unspoken agreement that cultural things just have to be accepted. It ends any minor dispute. Do it my way because that's how I was raised. And I thought that's really cool if they know that the other person, when they drop the science card or the culture card, this is the way my culture is. Please respect my culture. And the other one did that. There was this reciprocated respect between the two cultures, going back to Rocky wanting Ryland to watch him sleep. That was a cultural thing.
It's not a pop culture reference, but it's something that I found myself saying recently. So I've got a daughter who's going to be turning 1, and she's currently teething a lot. And since she's teething at night, she's in a lot of pain, a lot of discomfort. And so she finds comfort when she sleeps. I watch by rocking her up and down. And so I just multiple times in my life the last few weeks as those daggers are poking through, I'm thinking about Rocky and being like, hey, I watch you sleep. Now, I really wish it could maybe be the other way around because I would love a little bit more sleep, but I think that's the job of the parents. I watch you sleep.
I love that example. Your time will come, Paul. My quote isn't directly from the book, but I did come across a beautiful quote this week in the New York Times that books connect us. And I just think that really applies to what we're doing here with this common read, that we're connecting through this book across different areas of study and connecting all these voices across campus. So I just thought that was something beautiful that I wanted to share with you all.
And I agree with that. The fact that Joe really gets deep into the subatomic particles, you can hear it in his voice. And then Paul, going off to all the biology. And even when we brought in Mike Nagel and Sonia, there's sort of something for everyone. It really does bring a campus together. You've been listening to The Fox Den, a podcast series from West Shore Community College. This has been a review of the Winter 2023 Book of the Semester, Project Hail Mary by Andy Weir, chapters 13 through 18. Join us in 2 weeks for our review of chapters 19 through 24. Until then, I'm Wade James.
And I'm Joe Grahusky.
And I'm Patty Skinner.
And I'm Paul Belinsky.
That sounds a lot different than I remembered.
What you gonna go with here, Paul?
Monkey see, monkey do.
And I don't want Rocky to rot.
This might take a couple takes.
Ba-dum-bum.